you have calcium hydroxide reacting with nitric acid, yes, I'm videoing again, so you guys keep working. I'm just going to try to explain this problem on board. Calcium nitrate and HOH, you make 2 of those and 2 of those. When you take your, what are the values? 10 times 0.5, 10 milliliters times 0.5 molar, you get 5 millimoles of this one, and then 25 times 0.35, 25 milliliters times 0.35 molar is, I'm just going to get louder, that's all good, 0.35 is 8.75 millimoles. Then you put those numbers over here, 5 millimoles, 8.75 millimoles. Here's the trick for doing LR in your head. You take the coefficient of each of these, they are important, and you do 8.75 divided by 2, 5 divided by 1. This gives you 5. This gives you 4.375. So this one you have less of, so this is your LR. So this one's your LR. You minus all of the original value, minus 8.75 millimoles. You ignore this mess now. It's just there to help you figure out who your LR is. Same thing with this. Ignore. Take your original value minus 8.75 millimoles, but the coefficients tell you the way in which they react. So you take whatever you have for your coefficient of the one you're dealing with on top, so you're multiplying by a fraction, which is in the fraction, I mean mole fraction or mole ratio, divided by the 2, which is the limiting reagent. So that pretty much is telling you that you only are going to consume half of the calcium hydroxide, or half of this 8.75 number, in order to react fully with all that calcium hydroxide. So this makes sense because you end up with 0 of your LR, 875 minus 8.75, and then 5 minus half of 8.75 is 0.625 millimoles of the calcium hydroxide left over. Take your total volume and divide now on your millimoles of calcium hydroxide, which is 25 plus 35, or plus 10, which is 35 milliliters. Your millis and millis cancel out. That gives you moles per liter. This gives you concentration of calcium hydroxide to be 0.01786 molar. And since calcium hydroxide, when it dissociates, makes calcium 2 plus and 2 OH minuses, it doubles its concentration as it dissociates, which means that you take this number and you multiply by 2 to get your total OH concentration. So when you double that, you get OH to be 0.0357 molar. Use this to find the POH, and then do 14 minus POH to give you pH. So that is negative log of the OH concentration, which is 1.45, and then 14 minus that is 12.55, and that makes sense because it's a base in the basic, that pH lies in the basic region. Anybody else get that right?
No. I'm not really have motivation to redo it.
I'm going to stop videoing.